Today we want to create a biome system. For that I use the Brushify add-in here to create different textures on that map, but you can use every landscape material, whatever you want, it doesn't matter. And another one that I use is, if you go to the plugin, I have the Rama plugin. It's the Victory plugin that I enabled here because I need a very specific function for that, and Rama created this in this plugin, and this plugin is free to use, and you can take a look in the Unreal Engine forum and you can find it easily. Yeah, the idea is now we want to find out or we want to create different biomes here on that map. You can see I created 4 of them. So here is a mountain area, there is a desert, here we have a Mediterranean or a forest area, and here's just a normal area with a global normal climate zone. And yeah, now we want to create this biome that the player exactly knows in which biome he currently is. So of course we could create this with the overlap volumes, but the problem is that we are restricted to specific shapes, and we cannot create very uniform forms like this one here in the middle. And yeah, for that I had another idea, and yeah, we want to use a Colormap to see where the player is and which biome he is currently in. And yeah, for that what I already did is I enabled here the world composition, and I created in the maps one light map which only contains all the lightning, and then the map here itself which only contains the landscape. Yeah, let's open the level editor. I want to make this current, and yeah, let's open the world composition. And yeah, you can see the size of the map, which will be very important in a few minutes. So we have a size of 24,800 times the same size, and you can take it as well if you maybe click here or hover over the upper edge. And then in the lower left corner you see it goes from minus 1200 12,400 up to plus 12,400. And yeah, what we want to do is now maybe I would move the camera a bit back that it's not in the image, and then we want to create an screenshot for that. I'm using here Guiazo for that, but you can use whatever you want. And let's save this the desktop. You can't see it. Okay, and now let's switch. Or yeah, we can close this. We'll come back to the Unreal Engine a bit later, and we will open GIMP. And first of all, I want to create a new field. And yeah, you see it was in 24,800 by 24,800, and I want to use this dimension divided by 100 as resolution for this map. make it a bit easier. And yeah, let's create this map, and then I can simply drop this map in here. Yeah, we have to change it a bit, or smaller the size that it fits here exactly. So I want to scale it that you can slightly not see the orange borders. This one also here. Let's check it out. 2 pixels. We can go 2 pixels more. Yeah, so I think this is fine. This is good enough. And yeah, we will shrink it to the surface, and then we will have these our map, which will be our color map then, or our biome map. And we will draw with different colors, but we have to make sure that the color is well defined. So first of all, we will use black, which is in RGB and alpha, RGB of 0 and alpha value of 1. Of course, we will just use alpha values of 1. And yeah, let's draw in black maybe here the mountain area. And so, I will have this in the front, but you can see it here that I draw on the other lower level on the that one, this map. And yeah, let's maybe draw the desert in well-defined red. So, and yeah, we can leave the middle in white and just draw maybe the forest area here in green. So we will change it to 100% of green, and then I want to draw the borders of the forest area. Then I can switch back and draw it out. Of course, you can choose whatever color you want, but it's easier if they have a difference in their values, so it's easier to differ them. And yeah, that's good enough for us, so we will export this function and maybe call it tutorial color map. So tut color map point, and yeah, we can export it and save it. That's it. So we can then maybe we will create another folder just for the biome, and then we can import the color map. And to use this map, we have to change a few of these settings. So as you can see here, we want to change the compression settings to a vector displacement map. This is one of these, and we want to disable the sRGB value. This is necessary for the function that I'm using from the from Rama's plugin. And yeah, we have to go to no map, and I want to go to 8-bit data. And yeah, let's save it, and we're ready to go with that. Yeah, so we have to create a structure to store all the data for the biome. So I go to the blueprints, create a structure, which is my biome structure or biome struct. And that I will use a text because it's localizable and we can translate it later. Then yeah, this is the biome name, and we will have maybe a description for the biomes later. And one of the important things is the linear color, of course, which is the color map color. So the map color is this, and yeah, we want to have more data implemented, so we need an F curve or a float curve, which is the temperature curve. And here we can add two another values. Let's name it growth factor. And yeah, maybe another factor which means how wet is this area, so it's the humidity factor. So we can save it, it's float as well. And yeah, we want to create a database out of this. So we will data table, and we will pick then the biome structure and database biome. And yeah, let's create some data. So we have our color map here. Then let's see what we need. So yeah, let's try to create a few of these biomes. So maybe we want to start with an mountain area, mountain zone, and yeah, we leave it the description for now, and it's this value, and we will change the values later, maybe just to have the name and the data insert. And now we have to think about the row name, and we will use the color as well as for the name, but just within specified precision. And I think just 3 digits is fine, and then we have 3 for the R values, and we will use an underline, another 3 digits for the G and B value, and then it's 1 for the alpha value, and we can create another zone, which is maybe now the desert. And we will have a red value for that. So this is 1 0 0 1, and we will use this 1 0 0 and 1 for the desert, and we will add this for the two missing areas as well. One is maybe the tiger area, so that's the forest area. We want to create this one, and we want to create a Mediterranean area. and we maybe want to create an just a simple temperated area, or temperated climate zone. Let's be consistent. Rename them. And we have to change the color and our temperated zone at the white area. So we will go a lot of zeros and just a 1 for the alpha values. Oh no, a lot of 1s. I mean for a white value. And the tiger zone is green value, so our green value is 1, and we have a 0 for the red, 1 for green, and a 0 for blue, and a 1 for the alpha. Yeah, that's it for now. Of course, you can create different zones, specify whatever you want. Yeah, but for now that's good enough. And yeah, let's then create a function library to use the different functions. Blueprint function library for the biome. And yeah, the idea is that we want to use the image and use the values of the image to get that information in which biome we are. So first of all, we need an get biome by color function, and the input is a linear color. So this is the color of the map, and the output will be, of course, our biome structure that we created. This is our biome. So, and yeah, let's start. We will get data table row name. So we have our database biome, and then we are looking for the row name, and yeah, we have to create another function for that. We want to convert the color to a string value. So here we need an input. This will be the input parameter, which is the linear color as well. And an output, which is just a simple string, which is yeah, the biome string maybe. Okay. Let's split this or break that up. And what we want to do is we want to have a specific precision just for this value. So we said we want to have 2 digits after the point or comma and 1 before. So let's searching for precision. String conversion could float a string with precision, and we have the C and including the 0, the leading 0. Yeah, just copy that for all of these values, for the green, for the blue, and the alpha value. And now we want to append them and create a string which consists different underlines in between. And yeah, so what this is doing is changing the 1.0000 or whatever value we have just to 1.00. And now we want to replace the comma or the point with nothing. So we need the replace. We have comma, and we replace it with nothing. And yeah, let's have this for all of our strings. And then we combine the R, G, B, and alpha value. We will create this one, and now we will can get the biome. The convert will use both, maybe as an, or maybe this not. We will use this as a pure call. And then we have the color as an input. And of course we have to convert then the string to the name. And yeah, that's it here for the biome. But of course, the problem with this map, and we can maybe open that, and you see in some of these areas you do not have a completely 100% perfect value. So this is not black and not green, it's more grayish color. And if the player is exactly here in this area, then we would get no information about the biome because we did not store this value. So I say only if I found the row I can directly export it, and if I not found it, so I have to search all of my biomes and find the closest one. What I'm doing here is I will get all of the data table row names in the biome data. Here, this one, and I will loop overall for each loop. Of course, I have to check which of them is the closest one for me. And yeah, of course, I get data table row. This also the biome, of course. Then I can break the struct here, and I use the color from here. And another reroute one here, and just want to use the just the map color now, and we want to compare them. And here it's the color, it's in it's in 4-dimensional vector, so let's divide these both colors, and I want to have the length of a 4-dimensional vector for length, but you see it does not work, so let's break it and make the vector here and break it, the color here. So that's the value, and yeah, we will store the value in a variable, which is the margin, and we will set it, but we will only set it if it this length is smaller than the current margin. And normally this vector should not have a very high value, but I can start with maybe 1 or 10,000, so that the first value is in every case smaller than this, and then we can set it up here, and that's fine. And here, of course, we have to store the biome. So it's the log biome. Want to store but only if the distance from the wanted zone to the currently running zone here is smaller than the last founded. And yeah, that's fine, and then we can return it here, the biome. Yeah, that's it. So now we want to implement this maybe in, let's try it first in the corrector, maybe just use an key press to test it. And yeah, what we need is we have to the actual position, and we want to have the picture, and then now the function from the Victory plugin is we can take into account, and this function is called get pixels from get pixel array. So we can use this, and we have the color map, this one, and we have the actual location, of course. So, and we know that our value is now from minus 12,400, which was the upper left corner, up to plus 12,400 in the right corner, and our image goes yeah, from 0 to 248. So we have to shift it and divide the value. So we have to divide this first by 100. So now from 12,400 we are up to 124 plus minus, and let's break it because we do not want to check the set value. We just care about x and y, and yeah, we have to shift it by the half of the position by the half of the image. So we divide this also by 2 for both. And yeah, then we have to add this one to the x. And we want to do this the same for the y. Perfect. And yeah, let's store it in a few variables. So we promote this to the yeah, okay, we can store it first here, x position, and start this one to y position. And yeah, there is another function which is the get pixel function, which contains these and the height of the image, and say I want to which of the value for the x and the y pixel you want to ask. but currently in this version in 4.26 this function is not working, so we have to write our own function for that. But it's not difficult, so it's fine. We want to go back and we say, okay, we want to get the pixel. And what we insert as an information, let's see which is, this is an array of a linear color. So it's an array of linear color. So this is our pixel array. And yeah, what's also important, of course, we want the information which x and which y location we want to see. So it's x position and y position here. And I also need the information of the width of the images. So because in that function I will get an array and I will get the number of the array pixels, which is just linear, and here I have an x and y position, so I have to convert my 2D factors to one array factor. So I need the width of the image or the texture. And let's also return as a return value. We will have the just a linear color, which is my result pixel info or pixel color. So that, and then this function is very simple. I get copy of this, and this is already my result. I just have to multiply the y position with the texture width, this one here, and then I have to add the x, yeah, and that's it already. So now we have the x position of the image, y position of the image we want to see. We know the texture width, and we get the pixel information from here. And yeah, so what we can do now, we can go back here, and we have this texture width. So I will use this information, and we will get pixel. First of all, we want to get the pixel. We'll go with that, and we have the texture here, and then we have these two values we stored. It's the x position in image coordinates and the y position, and then we want to transform the color information into a biome. So we want to get biome by color, and we get a biome. And yeah, we want, for now we want to print the information out of the biome name. So this is all handled here with the one of the button, and we press, and then we print it out on our screen. And yeah, let's see if this works. maybe we will go back. So now we are here in this area. You see we are in the temperated zone, and I will quickly move here into the desert, and you see, oh no, we are in the desert zone, and let's run back, and I will hit the button. And now we have here the switch of the areas, and we will go run towards the mountain zone. And let's see, now it's switching. And yeah, let's run inside of the wall and see, we are now in the tiger zone. And yeah, it's working now. And with this information, for now, we can handle that and take a few of the parameters. For example, we can change the temperature, and this is something we want to do in the next part. We want to change the temperature, but first of all, because the temperature of these two zones, for example, in the desert or the temperated zone, can vary a lot, and we want to not to have a switch like here it's maybe 25 degrees and then I move 10 meters further and I'm at 40 degrees. So we need some planting in between these biomes, and this is what we want to implement in the next part. So thank you already for your visiting, and yeah, let's see you in the next part.